Good day! This is Johnny A. Abueg, Master Teacher 1 of Bagbag II Elementary School, Municipality of Rosario, Division of Cavite. My action research is about Japanese problem solving, strategy to improve the academic performance in mathematics of grade 5 pupils in Bagbag II Elementary School. For the rationale, based on the consolidated list mastered competencies last school year 2018-2019, second grading period in Mathematics 5 yielded the most number of list mastered competencies. Majority of the grade 5 pupils have difficulty in understanding the concepts and have problem in computation skills, thus resulting to poor academic performance in mathematics. In result, the researcher adapted the Japanese problem solving to improve the academic performance in mathematics of the said pupils. Research questions. First, what is the result of the pretest of the participants of the study? Second, what is the result of the post-test of the participants of the study? Third, is there a statistically significant difference on the pre-test and post-test of the participants of the study? For the research limitations and implications, this study will add to the limited local studies about Japanese problem solving. For the proposed intervention, Japanese problem solving aims to introduce open-ended problems in order not only to enhance learners' academic performance and higher-order thinking skills, but also to enable them to use their previous knowledge and skills to learn something new through the process of problem solving. The Japanese problem solving is composed of 4 pedagogical steps according to groups of 2018. The first one is what we call the Hatsumon, or presentation of the problem. Students try to understand the problem. It means asking a key question for provoking students' thinking at a particular point in a lesson. Students understand the context embedded in the task, as well as the corresponding mathematical condition that would be used to solve the task. The second one is the Kikanshido, or problem solving by the students. Students try to solve the problem. It means an instruction at the student's desk includes a purposeful scanning by the teacher of students' problem solving on their own. Purposeful scanning takes place while the students are working individually or in group, which allow the teachers not only to monitor students' strategies, but also to orchestrate their reports on their solution. The third one is what we call the Neriage, means to compare and discuss in Japanese. Neriage is a whole class discussion. There is a term for describing the dynamic and collaborative nature of whole class discussion in the lesson. During the comparison and discussion period, solutions by the students are presented. It also highlights the similarities and differences among student solutions. Teacher carefully calls on students in random or in draw lots to present problem on the board. It encourages students to show ideas in relation to math connection. The teacher's role is not only to point out the best solution, but to guide the discussion by the students toward an integrated idea. It's also called the heart of the problem-solving lesson. The fourth one is what we call the matome, or what we call summing up. Ending a lesson without summing up leaves the students feeling unsatisfied with what was presented to them. Summing up a lesson allows teacher to foster both student satisfaction and mathematical satisfaction. What students have discussed in the whole class discussion is reviewed briefly, and what they have learned through the lesson is summarized by the teacher. For the methodology, pre-experimental, pre-test, post-test design. Top 30 grade 5 pupils with difficulties in understanding the mastering of the list competencies using purposive sampling technique. Validated 20-item test that will be adapted from Mathematics 5 module. Paired t-test was also used. For the result of research question number 1, for the pretest result, the minimum score is 5, the maximum score is 8, and the mean is 7.2300. For the result of research question number 2, for the post-test result, the minimum score is 18, the maximum score is 20, and the mean is 19.2600. For the result of research question number 3, for the comparison of the pretest and post-test result, the degree of freedom is 29. The t-value is negative 21.919, and the significant value is 0.000. It means that there is a significant difference in the pretest and post-test result of the participants after the conduct of the intervention or the use of Japanese problem solving as a strategy to improve the academic performance of the pupils in mathematics. As a conclusion, the findings revealed that after the integration of Japanese problem solving in teaching mathematics among the participants, improved their academic performance. This study promotes the adaptation of Japanese problem solving that aims to introduce open-ended problems in order not only to enhance learners' academic performance and higher-order thinking skills, but also to enable them to use their previous knowledge and skills to learn something new through the process of problem solving. For the action plan, in-service training and orientation about Japanese problem solving. Adaptation of Japanese problem solving. Innovation. For the references, thank you very much.